Okay, today we're solving problems using quadratic equations. Let's just review what we've done last day. We learned about the quadratic formula. And so right now we're going to solve this equation. We know our A value is 2, our B value is -5, and our value of C is +1. So we're armed with these three values, and we're going to sub them into the quadratic formula. In order to solve that, we know x is equal to, let's try that again, x is equal to negative b. In this case, b is -5, so -1 times -5 we can say is +5, plus or minus the square root of b squared, which is -5 squared, minus 4 times a, which is 2, times c, which is 1. The entire thing is divided by or over 2a, which is 2 times 2. In this case, we get 5 plus or minus the square root of 25 minus, and 4 times 2 is 8, times 1 is still 8, all over 4. And that's going to equal 5 plus or minus the square root of 25 minus 8. That would be the square root of 17, all over 4. So we can look at what we're left with here. We have a, which is +5 divided by 4, plus or minus the square root of 17 over 4. That's our answer. This question here asks us, which one of the following parabolas has no real roots? So in order to figure out whether or not there are no real roots, one thing we looked at last day is if you have b squared minus 4ac, and if you end up with a negative, or for example, if you look at this equation that we just completed, if this were a -17, then we know that the square root of a negative number is not real because there is no number that multiplies by itself to get a negative square root. And I think I gave the example of -5 squared would be +25, and so the square root of 25 can either be, sorry, I apologize, and +5 squared is also 25. So the square root of 25 could be +5 or -5, but there's nothing that multiplies by itself that could give me a -25 or the square root of a -25, because whether I have -5 squared or +5 squared, my answer is +25. So having a negative square root, we say is not really a real root. So basically, which one of these will, under the square root symbol, which is also known as the discriminant, sounds like The Revenant, like a movie or something. The discriminant is the square root of b squared minus 4ac. And if the discriminant is equal to, I'm going to do it down here for you. If b squared minus 4ac is equal to a negative number, then we say there are no real roots. So 0. If the discriminant, and you might want to write this down as a little cheat sheet, if it equal a positive, then we say it has 2 roots. And if the discriminant is equal to, if you end up calculating it and ends up equaling 0, the square root of 0, then we say it has 1 root. And what that looks like, 1 root would look something like this, right? And 2 roots, of course, would look something like that. No roots would look something like this, where it doesn't cross the x-axis, so there are no roots. Okay, so let's look up here. Which one of the following parabolas has no real roots? So which one of these is going to give us, as I mentioned here, if it has no real roots, then which one is going to give us a negative under the square root symbol? In order to do that properly, you'll notice if you work with a few of them, you'll realize this is the one. So all you have to do is look at the b squared minus 4ac. And b squared here, the b squared would be -1 squared, which is 1, minus 4 times a, which is -4, times c, which is -1. Because we have, I'll highlight it, because we have negative, let's undo that. Because you have negative 1, 2, 3 times, our answer there is going to be negative because the negative doesn't wash out. If you have two negatives, of course, they'll multiply to become positive. But once we get three negatives, now we know our answer is going to be negative. And this, of course, is going to be the square root of, well, 1 minus 4 times negative 4 is negative 16. Negative 16 times negative 1 is negative 16 times negative 1 is positive 16. So I have 1 minus positive 16, which is equal to the square root of negative 15. And so that would give us no real roots. Okay, let's say, look at this one. Howard is trying to find, let's look at our learning goals first, sorry. The length area relationships are quadratic since area is length times a length measured in square units. The solution to some problems can be determined by multiplying two linear expressions together, which results in a quadratic equation. So just like the first one says, length, if you multiply length times length, you'll get squared units. And so when you're multiplying two linear expressions, you get quadratic or square units. Okay, Howard is trying to find two consecutive numbers, the key here being the consecutive, whose product is 18,632. You'll recall that product is the result of two factors being multiplied together. So we're looking for two numbers that happen to be consecutive, one after the other, and they produce are multiplied to produce a number 18,632. Which of the following quadratic equations can be part of his correct solution? Well, if we have two consecutive numbers, we'll say let x, I'll just do short form, represent the first number, and we'll say let x plus 1 rep the second number. We'll do that. So if I had my first number times my second number, because it was a product, and that's going to equal 18,632. If I use the distributive property here, I have x times x and x times positive 1. If I do that, x times x, of course, is x squared, and x times positive 1 is positive x. And that would equal 18,632. If I subtract 18,632 from both sides, or as some of you like to think of it, bringing it over, I end up with x squared plus x minus 18,632 equals 0. And that's what we have right here. So our answer is C. All right, the height of a triangle is 5 centimeters more than twice its base. So let's just try and visualize that. We have a triangle, and the base is the height of a triangle is 5 centimeters more than twice its base. The area of the triangle is 21 square centimeters. What is the length of the base of the triangle? We don't know what the length of the base is, so we're going to call the length of the base x. But then we know the height of that triangle is going to be 5 centimeters more than twice the base. So twice the base plus 5, which is 5 centimeters more than twice the base. And the area we know is equal to 21 square centimeters. So we know area of a triangle is base times height, like this, base times height divided by 2, which in this case is x times 2x plus 5 divided by 2, and the area we know is 21 square centimeters. I'm going to just cut this part out and move it if I can. Just move this down. Let's get rid of this first. Sorry about that. But let's cut this and move it down to give us some more room. There we go. And now we have some cross multiplication we want to do. So we're going to multiply 21 times 2 and the imaginary denominator 1 here times our numerator there. So 21 times 2, of course, is 42 equals x times 2x plus 5 times 1, and then x times 2x plus 5. That's what we're going to say. And so 42 equal x times 2x is 2x squared, and x times positive 5 is positive 5x. And then we're going to bring this or subtract 42 from both sides to get it there. So 0 equal 2x squared plus 5x minus 42. And given that we're now going to factor this. We're looking for a greatest common factor first. There is no greatest common factor between 2 and 5 and 42, so therefore we're going to multiply a times c. In this case, a times c is 84. So I'll just put that here. A times c equal 84. We want two numbers that multiply to 84 and have a sum has to equal positive 5. And um, we know that 84 is really 12 times 7. That works. And if we have a positive 12 and a negative 7, they would multiply to negative 42, and they would also add up to have a sum of positive 5. So we're going to say 0 equal 2x squared plus 12x minus 7x minus 42. So that's decomposition. What we've really done here is we just broken down our middle term into positive 12x minus 7x, but they still have a sum of positive 5x. And then what we're going to do is we're going to GCF these two terms and GCF those two terms. And so I get 2x times x plus 6 and minus 7 times x plus 6. So I get 0 equal x plus 6 and of course 2x minus 7. I guess I didn't bring that far enough down, so we'll do that now. And hopefully that's good enough. Maybe not. One more go. Okay. Now armed with that, we know in order for this to equal 0, either x plus 6 equals 0 or 2x minus 7 equals 0. So x plus 6 equals 0 or 2x minus 7 equals 0. If x plus 6 equals 0, then x equals negative 6. And if 2x minus 7 equals 0, we say 2x equals 7, divide both sides by 2, and x equals 7 over 2, which is really 3.5. So we have two possible answers. If x equals negative 6, then the base of our triangle would have a negative length, and that makes no sense. So in this case, the only valid root that works for this question would be 3.5, as you can see there. So we're going to say x equal 3.5 centimeters, and that's the answer to this question. The length of the base of the triangle is 3.5 centimeters. Okay, that's it for this lesson, and we'll see you in class.